Imagine you're taking, a classic American road trip.
Oh, absolutely. Windows down, music up.
Right. And you're cruising down the highway, the gas gauge uh, dips toward empty, and you don't even sweat it
No, not at all.
because you just look for the next glowing neon sign, you pull off at a familiar exit, and fuel up. I mean, it's a massive, sprawling infrastructure that we
Yeah.
just entirely take for granted.
We really do.
But now, imagine you cross a county line, the neon signs just vanish, and your dashboard map shows that the next fuel stop it just doesn't exist.
Yeah, it feels like staring into a geographic void, honestly. When you are the one behind the wheel in an unfamiliar, isolated stretch of country, that disappearing infrastructure is incredibly unsettling.
It really is. And that feeling of looking at a map with half the roads leading nowhere, that is the current reality of electric vehicle infrastructure,
Mm.
the moment you step outside of a major metropolitan area.
Which is a huge problem.
Exactly. Okay, let's unpack this. Today, our mission on this deep dive is exploring the massive shift toward electric vehicles or EVs. But we are looking right past the usual urban narratives.
Right, getting out of the city.
Yeah, we are heading out to the country to uncover the massive rural infrastructure challenge. And we're going to examine the surprising, highly funded tech startups that are just racing to fix it.
It's a fascinating space right now.
Totally. And we're pulling from two really incredible sources for you today. First, a U.S. Department of Transportation, or DOT, toolkit for rural EV planning that was published in 2022.
Yeah.
And second, an industry intelligence report by Gray B looking at innovative EV charging startups poised for impact in 2026.
You know, these sources pair beautifully together because they highlight just this glaring contradiction.
How so?
Well, on one hand, you have the government establishing this monumental goal reaching 50% EV sales by 2030 and building a national network of like 500,000 chargers.
Right, which sounds great on paper.
Exactly. But then you look at the reality on the ground, and rural EV adoption is sitting roughly 40% lower than in urban areas right now.
I mean, that's a massive gap, especially considering the sheer geography involved.
Absolutely. To set the stakes for you here, we have to recognize what rural America actually looks like on a map. Rural areas account for just 20% of the U.S. population.
Okay, so a fifth of the people.
Right. Yet, they contain 70% of the nation's road miles.
Wow. 20% of the people, but 70% of the pavement.
Yeah. Which means the lack of charging infrastructure out there creates a severe range anxiety bottleneck. People
Yeah.
are just terrified of being stranded in the middle of nowhere.
I mean, I would be too.
Right. But what the DOT data clearly shows is that the potential economic benefits for these rural communities are staggering if we can just figure out how to bridge that infrastructure gap.
Okay, but wait, I have to play devil's advocate for a second here.
Sure, go for it.
Because when you think of an EV, the image that usually comes to mind is like a sleek little car zipping through city traffic, a commuter vehicle.
Right, a Tesla in a parking garage.
Exactly.
Mm-hmm.
If you live in a rural area and maybe you drive, I don't know, a heavy-duty pickup truck, long distances over rough terrain, why on earth would you make the switch? I mean, it feels completely counterintuitive to the lifestyle.
Yeah, the initial perception definitely leans that way. But the underlying math tells a completely different story. The DOT data breaks down the economics of rural driving in a way that is just hard to ignore.
Okay, let's hear it.
So rural residents actually drive about 10 miles more per day on average than urbanites.
Makes sense. Things are farther apart.
Right. And because they are driving further, often in larger, less fuel-efficient vehicles, transportation eats up a massive 20% of a rural household's budget.
A fifth of everything they earn is just going toward getting around.
Exactly.
Man, how does that compare to city drivers?
For urban households, transportation is about 15.7% of their budget. So, rural drivers are spending roughly 44% more on gas and motor oil than urban drivers.
Oh, wow.
Yeah. And this brings us to a phenomenon we can call the total cost of ownership illusion.
Right, the sticker shock at the dealership. Like you walk onto the lot, the EV has a higher upfront price tag, and it is incredibly easy to just walk away assuming you can't afford it.
Right, but that upfront price completely obscures the operational reality. Let's just look at the physics of it for a second.
Okay.
EVs are, on average, 3.6 times more energy efficient than a comparable gas-powered vehicle.
Because there's no combustion.
Exactly. An internal combustion engine loses most of its energy to heat and friction. But an electric motor puts almost all of its energy directly into turning the wheels.
Makes sense.
So because of that efficiency, if you drive 15,000 miles in a year, the electricity to power an EV is going to cost you roughly $546.
Okay, and the gas equivalent.
The equivalent amount of gasoline to go that same distance. That averages out to $1,255.
Wait, really? You're saving over $700 a year just on the fuel alone.
Just on the fuel.
That's wild. But it doesn't stop at the fuel pump either, right? The DOT source pointed out something that fundamentally shifts the whole maintenance paradigm.
Oh, absolutely.
Like EVs don't have spark plugs. They don't have transmission fluid to flush. They don't even use engine oil. You are stripping out hundreds of moving metal parts that constantly wear each other down.
Which breaks all the time.
Right. So the maintenance is up to 50% cheaper over the entire life of the vehicle.
It fundamentally changes the household ledger. I mean, you are replacing a complex mechanical machine with what is essentially a computer on wheels.
And there is this series performance perk here too, which surprised me.
Oh, the torque.
Yeah. The DOT data highlights that because EVs don't have traditional geared transmissions, the electric motors generate full torque instantly from a dead stop.
Right, no revving up.
Exactly. So if you were doing demanding rural tasks like towing a heavy trailer, hauling feet up an incline, you actually get much better, smoother towing capacity.
Yeah.
So when you look past that initial sticker price, transitioning to an EV isn't just about making a quote-unquote green choice. It is a profound financial pivot for families that are currently dumping 20% of their income into their gas tanks.
What's fascinating here is that the economics make absolute sense for the individual driver. The benefits are totally clear. But that introduces a massive puzzle.
Right, the catch.
Yeah. If it's such an incredible financial deal for the driver, why aren't there fast chargers on every rural corner?
And that physical limitation is where the entire system bottlenecks.
Precisely.
The rural electric grid.
Let's get into the weeds on this a bit, because this is where the Graby Intelligence Report really starts shining a light on the structural problems.
Yeah, to understand the grid bottleneck, we have to look at the actual hardware requirements. If you want to charge an EV quickly on the highway, mimicking a gas station experience, you need direct current fast charging, or DCFC.
Okay. These stations push a tremendous amount of direct current straight into the car's battery, taking it to 80% capacity in maybe 20 to 60 minutes, but pulling that off requires massive, instantaneous amounts of power.
Which an aging rural power line strung up in the 1950s just isn't built to deliver.
Exactly the problem. Most rural grids run on single-phase power, which is fine for lighting a farmhouse or running a standard appliance.
Right.
But to handle the sheer volume of electricity a fast charger demands, you need a commercial-grade, three-phase power line.
And that's not cheap, I assume.
No, it's incredibly expensive. Upgrading a rural grid to three-phase power means physically running miles of heavy new cables down isolated country roads. We are talking about hundreds of thousands, sometimes millions of dollars, just to get the right wire to the site.
Wow, okay, but let's say a local gas station owner actually secures a grant, right?
Yeah.
They run the three-phase wire, and they install the charger. The DOT toolkit points out that they are still likely to lose money because of how utility companies bill for electricity.
Oh, the demand charges.
Yeah.
This is the hidden killer of rural EV infrastructure. You see, utilities don't just charge commercial customers for the total amount of electricity they use.
Right, that would be too simple.
Exactly. They charge steep premium rates for the maximum rate at which they pull power during peak times.
Okay, so imagine our rural fast charging station. It might only see, 2 or 3 EV drivers a day?
Probably, yeah.
But at 2.8 p.m., a driver pulls up and plugs in, demanding an enormous spike of electricity all at once to get that 20-minute fast charge.
Right.
The utility company hits the station owner with a massive demand charge for that spike.
A huge penalty, basically.
Yeah, and the revenue from selling electricity to just 3 drivers doesn't even come close to covering the penalty fee for that one power spike.
Exactly. The DOT notes that without outside incentives, a rural fast charger's revenue typically only covers about 1/3 of its operating costs.
That is just wild.
It is a fundamentally broken business model. You cannot build the future of transportation on an economic model that guarantees a loss. But this is exactly where the hardware startups are stepping in. They are looking at this broken grid and saying, let's just bypass the traditional limitations entirely.
Okay, here's where it gets really interesting. You have companies realizing that if the grid is the bottleneck, the solution is decoupling from the grid's limitations.
Yes.
The Gray Bee report highlights a U.S. startup called FreeWire Technologies that has raised over $230 million to solve this exact problem with something they call the boost charger.
Yeah, their engineering approach is brilliant because it smooths out the demand curve.
It really is. Okay, so the boost charger has a massive battery integrated right into the charging unit itself.
Right.
Think of it kind of like a toilet tank.
A toilet tank.
Yeah, stick with me here. It connects to the existing low-voltage, single-phase rural infrastructure that is already there, right? All day and all night, it fills up its internal battery very, very slowly. It just sips power from the grid without ever triggering a spike.
Ah, I see where you're going with this.
Yeah. But then when a car pulls up and plugs in, it acts like a flush. It dumps all that stored power from its internal battery rapidly into the car.
That's actually a great analogy.
Why?
By sipping power slowly, it completely dodges those peak utility demand charges. The utility company only sees a low, steady draw of electricity.
Exactly.
Furthermore, FreeWire notes that this saves about 40% on installation costs because you don't have to rip up miles of asphalt to lay three-phase utility lines. The existing grid is suddenly good enough.
I mean, it changes the game for a rural business owner. But then you have startups going even further off the grid, like getting rid of the fixed station entirely.
Oh, the mobile ones?
Yeah. The Gray Bee report outlines a U.S.-based startup called L-Charge. Instead of trenching cables into the ground, they operate mobile minivans equipped with onboard generators powered by clean fuels, like liquid natural gas or hydrogen.
Wow.
Yeah, these vans literally drive around, generating power on the go.
It is infrastructure on demand. One van can charge up to 48 cars a day, generating 1,440 kilowatt hours of electricity daily.
That's a lot of power.
It is. And if a rural highway suddenly sees a surge of holiday traffic, you don't have to build 10 new permanent chargers that will just sit empty the rest of the year.
Right.
You just deploy a fleet of mobile charging vans to that corridor.
I love how these spatial problems are being tackled from multiple angles. Like, for instance, the report also mentioned urban electric networks out of the UK.
Ah, yeah, solving a completely different issue.
Exactly. They are solving the fact that 43% of UK households park on the street. Now, I know that is predominantly an urban stat, but think about small, rural town centers with historic main streets where there are no driveways, just curbside parking.
Right, you can't just run an extension cord out a second-story window across a public sidewalk.
Right, that'd be a nightmare. So Urban Electric created the UAN. It's an operated pop-up charging hub.
Like a bullard.
Yeah. When it's not being used, it retracts flush into the pavement so it doesn't clutter the sidewalk or block snowplows in the winter.
That's clever.
But when you need it, you activate the app, a pillar pops up, and it provides a slow 7-kilowatt charge overnight while you sleep. It's adapting the infrastructure to the environment, rather than forcing the environment to adapt to the infrastructure.
But you know, whenever we solve one engineering puzzle, we usually uncover another one.
Always.
We figured out how to bypass the grid to deliver ultra-fast power. But if we are blasting these car batteries with massive amounts of electricity to mimic a 10-minute gas station stop, we hit a wall with chemistry.
Oh, you're talking about battery degradation.
Specifically, yes.
Because heat is the ultimate enemy of a lithium-ion battery. The faster you push electricity in, the hotter the cells get. If you aren't careful, you can quite literally cook the battery, permanently degrading its capacity and ruining its lifespan.
Exactly. This comes down to internal resistance, or impedance. When you force electrical ions to move rapidly across a battery's internal structures, they face resistance, and that resistance generates intense heat. This is where a Canadian startup called G Batteries enters the picture, developing an adaptive algorithm known as ChargeSense.
ChargeSense, okay.
Yeah. Instead of flooding the battery with a continuous heavy stream of electricity, which causes that thermal buildup, ChargeSense uses what is called pulse charging.
Okay, walk me through the mechanism of pulse charging. How does that actually prevent the heat?
Well, the algorithm monitors the battery's internal condition in real time, checking its impedance. Instead of a steady flow, it fires the electricity in rapid pulses with microsecond pauses in between.
Microsecond pauses.
Right, and during those tiny pauses, the chemical ions inside the battery have a moment to settle. By not forcing a continuous wave against the battery's internal resistance, the heat simply doesn't build up.
Oh, I get it. Okay, so if conventional fast charging is like trying to chug a mug of piping hot coffee and severely burning your mouth, this ChargeSense algorithm is like taking rapid fire, tiny sips. You still get all the caffeine into your system the same amount of time, but you give your mouth just enough time between sips to cool down so you don't destroy your taste buds in the process.
Chemically speaking, that captures the dynamic perfectly. It allows for ultra-fast energy transfer without the thermal damage.
And it protects the lifespan of a very expensive vehicle, which is huge.
Absolutely.
But we aren't just dealing with chemistry, right? We are also dealing with a massive hardware compatibility headache.
Yes, the voltage gap.
Right. The Gray Bee report highlighted an Australian startup, Inverted Power, that uses fixed battery storage similar to FreeWire for high-power sprints. But they solve a very specific mismatch between the chargers and the cars.
And this is a critical transition period for the industry.
It is, because the automotive industry is currently upgrading. A lot of the newer ultra-fast EVs are being built on 800-volt architectures to allow for faster charging.
Right.
But the vast majority of the existing fast chargers sitting out on the highways are only built for 400 volts.
It's a huge problem.
Yeah, think of voltage like water pressure in a pipe. You are basically trying to connect a high-pressure system to a low-pressure hose.
Right?
So Inverted Power's technology acts as a bridge, actively managing the voltage so that those newer 800-volt cars can pull up to older 400-volt charging infrastructure and still work seamlessly.
Which is amazing because it prevents millions of dollars of existing early-generation rural infrastructure from becoming obsolete overnight.
Totally.
So if we look at the board, we have the hardware bypassing the grid, we have the mobile solutions, and we have the software managing the battery chemistry.
Right.
But having all these disparate pieces scattered across a rural landscape raises a crucial operational question. How do you actually orchestrate it all?
Right, because this requires an incredibly sophisticated layer of software.
The brains of the operation. Hardware is useless if you don't have the software to make it intelligent.
The Gray Bee report highlights a Netherlands-based startup called Jedlix as a prime example of this intelligence, right?
Yes, Jedlix. They specialize in over-the-air, or OTA, smart charging technology.
How does that work?
Here is how the mechanism works. You plug your car in at home in the evening, and you tell their app on your phone, hey, I need my car fully charged by 7 a.m. tomorrow.
Okay, pretty standard so far.
Right. But then Jedlix's software takes over. It doesn't just start blindly drawing power. It communicates with the utility grid, calculating the optimal moments to draw electricity based on 3 variables.
Which are?
The current capacity of the local grid, the moments when renewable energy like wind or solar is peaking and abundant, and when electricity rates hit rock bottom during the night.
Wow. So it is essentially day trading electricity while you sleep, ensuring you get the cheapest, greenest power possible by the time you wake up.
It is, but Jedlix's software scales this concept up into something called a virtual power plant, or a VPP.
Okay, wait, I'm stuck on this idea of a virtual power plant. How does networking a bunch of parked cars actually function as a power plant?
Think about a traditional power plant. On a sweltering summer afternoon, when everyone in a county gets home and turns on their air conditioning at the exact same time, the grid gets stressed.
Right, the classic brownout scenario.
Exactly. A traditional power plant has to rapidly fire up auxiliary generators to meet that spike in demand, which is expensive and highly polluting.
Yeah.
A virtual power plant solves the problem from the opposite direction. By controlling thousands of plugged-in car batteries, Jedlix's software can dynamically pause the charging of all those cars for just a few minutes during that air conditioning spike.
Oh, wow.
By instantly reducing demand, they balance the grid without needing a backup generator. The utility company actually pays Jedlix for providing this flexibility, and that financial value gets passed back to the EV driver.
That is wild. Your parked car is literally acting as a shock absorber for the local electrical grid.
Exactly.
By simply being plugged in, your vehicle is stabilizing the grid for the entire county. But, smart software isn't just about trading energy. It is also about physical survival.
How do you mean?
Well, in a rural area, a broken charger isn't just a minor inconvenience, it's a crisis. If you drive 40 miles to the only charger in the region and the screen is blank, you are completely stranded.
Oh, absolutely. Which is why the report features a U.S. startup called Ioteca, which developed a cloud-based platform called IoTON.
Right.
Their entire focus is on uptime and predictive analytics.
Right. They use AI to constantly monitor the health of the physical charger. Like, it's looking at the data streams and noticing things like a slight voltage drop in a cable, or, a cooling fan that is spinning a little too slowly.
Very subtle things.
Yeah, it flags these tiny anomalies and alerts a maintenance crew to replace the part before it physically snaps. It
Yeah.
basically guarantees that when you pull up to that rural station, the machine actually works.
So we have solved the grid, the chemistry, and the orchestration. But we have to ground all of this data back in the real world.
Right.
How does a small rural town actually leverage this technological shift?
Yeah.
The DOT toolkit lays out the socioeconomic impact beautifully.
It starts with economic development through captive tourism, right?
Yeah. The Federal Highway Administration runs a program mapping out alternative fuel corridors, covering tens of thousands of miles of highway.
Okay.
When a rural town sits on one of these corridors, installing a fast charger becomes a massive commercial draw. Because an EV still takes, 20 to 40 minutes to fast charge, the driver isn't just pumping gas for 3 minutes and speeding off.
Right. They are a captive audience.
Exactly.
If you are stuck there for half an hour, you are going to get out of the car. You are going to grab a coffee, buy a meal, maybe wander down Main Street into a local shop.
Yeah.
The DOT report mentioned an initiative between NATSO, which is the organization representing truck stops and travel plazas, and the network ChargePoint. They're aiming to put chargers in 4,000 truck stops.
That's a huge deal.
It is. Those rural stops suddenly transform from quick pit stops into prolonged commercial hubs for drivers taking cross-country trips.
And if we connect this to the bigger picture, EVs aren't just consumers of power, and they aren't just tourism drivers. They are highly mobile batteries that can provide unprecedented resilience for isolated areas.
Oh, this goes back to what we touched on with the virtual power plants, but on a more localized physical scale.
Yes. Some of the newer EV models, particularly the heavy-duty electric pickup trucks hitting the market, offer bidirectional charging.
Meaning power goes both ways.
Exactly. In a rural area prone to severe weather, where a blizzard or a fallen tree can knock out utility power for days, an EV can literally plug directly into a home's electrical panel.
It's incredible.
Based on average usage, a fully charged electric truck could power a standard house for up to 3 days during a total blackout.
Wait, 3 days? You were basically replacing the noisy, polluting diesel generator in the shed with the truck parked in your driveway.
Yeah. It is a massive resilience boost for communities that are usually the last to get their power restored after a storm.
And, the DOT toolkit actually offered a surprisingly simple, low-tech solution for rural mobility, alongside all these massive trucks and grid solutions. E-bikes.
Right. It's an important reality check. Not every single trip requires moving a 5,000-pound metal box.
Exactly. For a quick 2-mile run to the local store, or connecting a neighborhood to a rural transit stop, e-bikes are incredibly effective. And the best part,
They're cheap.
well, yes, but they don't require demand charges or 3-phase power. They plug into a standard 120-volt level 1 outlet. You just plug it into the wall like a toaster.
Right. So simple.
It drastically reduces local emissions and fuel costs for short trips, long before a town even manages to build out heavy EV infrastructure.
For the heavy infrastructure, though, communities don't have to tackle this alone. The funding and support landscape has shifted dramatically.
These grants.
The DOT toolkit details the $7.5 billion from the bipartisan infrastructure law specifically earmarked for EV chargers.
I mean, that is a staggering influx of capital dedicated to this exact problem.
But there are also the VW settlement funds, which are managed by state environmental agencies to mitigate emissions.
Oh, cool.
And for rural town planners who feel overwhelmed by navigating all this technology, the Department of Energy runs the Clean Cities Coalitions.
What's that?
It is a network of over 75 regional groups that provide free technical assistance. They help small towns navigate the complex grant applications, plan the grid connections, and even develop the local workforce needed to install and maintain these advanced systems.
So what does this all mean? When you look at the DOT's rural data alongside Graby's startup report, a very clear picture emerges for you as the listener. The EV revolution is not just a straightforward swap of gas for electricity.
It really isn't.
We aren't just unbolting a gas pump and bolting down a charging cable. It is a fundamental reimagining of how energy moves. It is being driven by nimble startups that are hacking their way around ancient, centralized infrastructure, allowing rural communities to find a new kind of economic revitalization through smart, decentralized technology.
I think that perfectly synthesizes the shift. But, I want to leave you with a final thought to mull over. Building on this idea of decentralized power and vast rural spaces.
Okay, Maddie.
We've talked about how virtual power plants allow cars to balance the local grid, and how rural areas have the space for massive solar and wind generation.
Right.
If you combine those two things, abundant renewable energy generation in the country and massive fleets of mobile EV batteries capable of storing it, we have to wonder, will the historical power dynamic between cities and rural areas flip entirely?
Wait, how do you mean?
Well, historically, rural areas have been dependent on centralized infrastructure radiating out from urban centers.
Sure.
But in a decade, a rural town with vast solar arrays and a fleet of networked EVs acting as a massive battery reserve could become a primary energy exporter.
Oh, wow.
During a severe summer heat wave, when a major city's grid is on the verge of collapsing, that city might literally have to buy its emergency power from the networked electric pickup trucks parked in rural driveways 100 miles away.
That is, wow.
The rural areas wouldn't just be participating in the grid, they could be the ones keeping the cities from going dark.
That is a staggering shift in perspective.
Hmm.
The rural county isn't the edge of the map anymore. It's the generator powering the center. It completely changes how we view movement, energy, and geography. Thank you so much for joining us on this deep dive into the rural EV landscape. There is so much engineering and economics happening just beneath the surface, so keep questioning, keep exploring, and we'll see you next time.